All right, now we're going to start finding distances between things, and we're going to find those distances using right triangles, so using the Pythagorean theorem. And so taking a look at these guys, again, the distance, sometimes when we measure the distance, we simply just count it. All right, when we're measuring with a ruler or a tape measure, we're simply counting the distance using the measurement that's given. All right, so on a coordinate plane like this, we can do the same thing. We could do it by counting, but only if they're lined up in a direction where we can count. For example, if I look at the distance from x to y, because x and y are lined up nicely, I can simply count the distance from one to the other. It's 1, 2, 3, 4, 5, 6, 7, 8 spaces. So the distance here is 8. So I'm just say, hey, the distance equals 8. All right? But then if I separately ask for the distance from x to z, the problem is I can't count diagonally. Just like the same problem I had with finding the midpoint, I can't count diagonally, so what I have to do is I have to find the distance in a slightly different way. What I do is I count in the directions that I know how to count. For example, x to y was 8 spaces, and if I count that almost like drawing the side of a triangle, now the side of that triangle is 8. Okay? But then if I count over from y to z as well, and again, create like the leg of a triangle, that is 1, 2, 3, 4, 5, 6 spaces. And so what I can do now, if the thing that I actually want to find is the distance from x to z, let me draw that. Hopefully you can see that what I've actually done here is I've drawn a right triangle. And when I look at this right triangle, I have the two legs. I'm missing the hypotenuse, okay? And so what I'll call it for this one is I'll call it C, all right? Because that's typically what we call the hypotenuse. And so to find the distance, to find the length of C, I'm going to use the Pythagorean theorem. So here, leg squared plus leg squared equals the hypotenuse squared. So 6 squared plus 8 squared equals C squared. And I solve, I simplify. 36 plus 64 equals the C squared. That's a 100 equals c squared. And once again, to solve with my Pythagorean theorem, I take the square root to get rid of the square. So I find out that c equals a 10. So the distance here is 10 units. So I'll change it to d. I'll say d is 10 this time instead of c. Okay? But essentially, I do the same thing that I've been doing. I just have to count the two legs of the triangle. Anytime I want to find the distance, I can form a right triangle and find the distance that way. If I look at these examples, same kind of thing. I want the distance from A to B, so I simply count from A to B, and I count in the two directions that I can, like I count over, and then I count up. Or I could count up and then over. Either way, I form this right triangle, and if I count this distance, it's 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces this way, and 2 spaces this way, and once again, I want to find the hypotenuse. And so anytime I want the distance here when I have 2 points, I simply count over and up and over, or down and over, and that gives me the legs of my triangle. And then I just have to find the hypotenuse. So here we go, a squared plus b squared equals c squared. And again, I'll call it c for now. And this time I get 85 equals the c squared. Once again, I take the square root in order to solve when something is squared. So here I get c equals, and this is a job for my calculator. Square root of 85. We'll just round it off. That gives me approximately a 9.23. And so again, that's the distance. The distance this time is 9.23, the distance from A to B. But I used a right triangle to find that, okay? From C to A, let me erase what I have, and I'll start over here. So C to A, once again, I count down and over. And when I count this, that's 1, 2, 3, 4, 5 spaces. Here, that's 1, 2, 3, 4, 5 spaces. And so once again, I've formed a right triangle where I'm looking for the hypotenuse. A squared plus b squared equals c squared. Again, I just simplify, combine these things, and now to solve, I take the square root. And again, use your calculator for this. I get about a 7.1. Okay, so that's the distance. The distance is 7.1. So again, anytime we have 2 points, we can just count over and up, or down and over. I count the legs. I just make a right triangle. I count the legs. I find the distance using the Pythagorean theorem.